It all kicks off with a sludge-colored soup called crude oil, thick, sticky, and fresh from the Earth's crust. This stuff gets shipped in by train, truck, tanker, or straight through buried pipelines depending on where you are. Once it lands at the refinery, it doesn't get a warm welcome, it gets cooked, literally. First stop, the furnace. Giant, fire-breathing units that take crude oil and crank the heat past 650 degrees Fahrenheit, sometimes up to 750 degrees Fahrenheit. Imagine tossing a pot of oil on an open flame, only it's thousands of barrels and the pot is a metal monster the size of a small building. This heat doesn't just loosen it up, it vaporizes it. Next, the now steaming oil vapor enters the atmospheric distillation tower, the refinery's version of a skyscraper. Inside, the vapor rises while the heavier liquids sink. Why? Because science loves temperature games. The lightest components float up to the top, while thick, heavy ones hang around the bottom like they missed leg day. Gasoline range vapors hang out near the upper middle floors, too heavy to float, too light to drop. It's all about where they condense or turn back into liquid at just the right temp, like a chemical high-rise with each compound getting off at its designated floor. And that, right there, is the refinery's first magic trick, separating one nasty black soup into useful building blocks. We're still a long way from the gas station pump, but this is where the makeover begins. Alright, we're still inside that tall metal tower, but now things are about to get really organized. Picture the inside like an oil-scented hotel with temperature-controlled floors. The whole concept? Fractionation. Fancy word, simple idea. Every hydrocarbon boils and condenses at a different temperature. So when that oil vapor rises up, it naturally splits itself based on weight and boiling point. At the bottom of the tower, it's too hot to handle. Only the heavyweights stay there. Think lubricants and bunker fuel, the thick stuff you don't want near your engine. A little higher up, diesel and kerosene settle in. They're heavier than gasoline, but lighter than tar. Kerosene's that jet fuel cousin, by the way. The kind of fuel that helps metal tubes fly across continents. Then comes naphtha, a gasoline precursor. It's not quite the finished product, but it's flirting with it. Up top, light gases like propane and butane. Those are the real floaters, sometimes skimmed off for cooking fuel or bottled up for your backyard grill. It's all about precision. You can't mix this stuff willy-nilly. Each floor of the tower has trays and bubble caps, little devices that catch and cool the vapor just enough to separate it from the crowd. Like a molecular bouncer saying, "You, naphtha, you belong on tray 10. Propane? Up you go, buddy." Now that we've sorted our hydrocarbons by boiling point like a nerdy librarian with a fire fetish, it's time to change their personalities. Some of those fractions, too heavy, too lazy, or just plain wrong for modern engines. So the refinery sends them to the gym, or the lab, depending on the vibe. Welcome to the conversion units, where big chunky molecules get broken down, restructured, or stitched together into high-performance fuel. First up, cracking. No, not the kind you hear at a chiropractor's office. This is molecular breaking and entering. Heavy fractions go into a reactor full of heat, pressure, and a catalyst that looks like fine sand. It's called fluid catalytic cracking, and it basically shatters long hydrocarbon chains into shorter, more useful pieces. That thick tar-like stuff? It can become sweet, flammable gasoline. Boom. Magic. Then there's reforming, which sounds polite but is absolutely wild. Low-octane naphtha gets rearranged into high-octane aromatics. Add some heat, a platinum catalyst, and hydrogen, and you've got Reformit, a premium gasoline ingredient. It's like upgrading a couch potato into an Olympic sprinter. And finally, alkylation. Sounds like a chemistry exam term, but this one's about building rather than breaking. It takes small leftover molecules, think isobutane and olefins, and fuses them into smooth, stable, high-octane components. Think of it like Frankenstein's lab, except what rises from the table is your future gas mileage. Alright, we've cracked it, we've reformed it, and we've Frankensteined it into premium fuel ingredients. But it still smells like it's been marinating in a dinosaur's armpit. That's because sulfur and a few other chemical misfits are still crashing the party. Left unchecked, sulfur will not only make your fuel smell like Satan's omelet, it'll also corrode your engine and poison the air. So now, it's time to clean house. Enter hydrodesulfurization, or HDS if you want to sound cool in refinery lingo. Basically, we send our freshly cooked fuel through another reactor, this time bubbling it with high-pressure hydrogen gas and a catalyst. The goal? Bond sulfur with hydrogen to form hydrogen sulfide, a gas that can be whisked away and treated separately. It's like giving your fuel a deep detox facial. But sulfur's not the only troublemaker. There are nitrogen compounds, metals, even funky-smelling mercaptans that make the whole place reek. So refineries use amine scrubbers, caustic washes, and sweetening units to tone it all down. It's less spa day and more hazmat makeover, but the result? Fuel that's stable, less toxic, and road ready. This part may not sound glamorous, but it's critical. Without this step, your car would run dirtier, your catalytic converter would suffer, and air quality would nosedive. Plus, modern emission laws don't mess around. So once our fuels are clean and polished, it's time to blend the perfect recipe. Gasoline isn't just one ingredient, it's a cocktail. And every season, the recipe changes. So, the crude's been cracked, cleaned, and reshaped like a molecular makeover show, but we're still not done. Because gasoline isn't one neat liquid that comes out ready to roll. It's a blend, baby. A custom cocktail of fuel components, each with its own flavor, volatility, and job to do. Think of it like mixing the perfect playlist. Except your engine is the DJ and the beats are octane levels. This is where all those processed streams come back together. Reformate, alkylate, cracked gasoline, maybe some butane, and a dash of ethanol for good measure. The refinery's goal? Hit the exact target for octane rating, vapor pressure, emissions limits, and whatever seasonal quirks the government requires. Yep, your summer gas and winter gas aren't twins. They're cousins who dress for different weather. In the summer, gasoline has to be less volatile, meaning it doesn't evaporate as easily, because hot air already stirs up fumes. In winter, they tweak the recipe to make it vaporize faster for cold starts. It's science mixed with logistics, mixed with a bit of meteorology. Oh, and don't forget the ethanol blend. Often 10% in the US, added for environmental regulations and a cleaner burn. It also boosts octane and makes big corn very happy. Once blended, the fuel is tested, adjusted, and tested again. Because one wrong ratio can mean engine knocking, emissions violations, or an epic fuel recall. Next stop, we're moving this magic mix out of the lab and into the real world. The shipping hustle is about to begin, now that our gasoline blend is perfectly mixed, like a molecular cocktail shaken, not stirred. It's time to move it. And trust me, this part isn't just put it in a truck and go. We're talking industrial scale logistics here. Think giant storage tanks, high pressure pumps, underground pipelines, and sometimes even boats. Yep, your fuel might have taken a cruise before hitting your tank. First, the fresh gasoline is pumped into enormous storage tanks, those wide, circular beasts you see at refinery edges. They're not just sitting pretty. These tanks keep the fuel sealed tight to avoid evaporation, contamination, or accidental fireworks. From here, gasoline flows into a network of pipelines, some running for hundreds of miles across states or even countries. Not every drop takes the pipe, though. Some batches go by rail, truck, or barge, especially when the destination isn't pipeline friendly. Each mode has its own strict safety rules because, well, it's flammable, really flammable. By the time it reaches a distribution terminal, it's tested again, like a fuel quality bouncer, making sure no bad blend sneaks into your neighborhood. Then finally, it's loaded onto fuel trucks, the ones you see refilling gas stations while you're grabbing snacks. Oh, and here's a fun fact. From every 42-gallon barrel of crude oil, we typically get about 19 to 20 gallons of gasoline. The rest becomes diesel, jet fuel, or other products. So next time you're at the pump, remember, your fuel's traveled farther, been tested harder, and handled more drama than most reality TV stars. Let's talk money next. So why go through all this fire-breathing, molecule-cracking madness just to make fuel? Simple. Gasoline is big money. Refining isn't a charity. It's a high-stakes game of chemistry and capitalism, and the scoreboard is constantly changing. At the heart of it all is something called the crack spread. Sounds illegal, but it's really just the profit margin refiners make from turning crude oil into refined products like gasoline and diesel. For example, if a barrel of crude costs $75 and the refined products from that barrel sell for $100 total, the crack spread is $25. That margin's what keeps refineries alive and expanding. But the math isn't simple. Prices swing based on global oil markets, demand spikes, supply chain glitches, weather events, even geopolitics. Hurricanes in the Gulf? That's trouble for refineries. War overseas? Suddenly oil prices shoot up. A refinery outage in Texas? Hello, gas price hike. And then there's the tech side. Not all refineries are created equal. Some are simple topping refineries, which mostly boil and separate crude. Others are complex, deep conversion monsters with dozens of units, crackers, reformers, alkylators that squeeze every last valuable molecule from a barrel. More complex means more flexibility, more efficiency, and yeah, more profit. Bottom line, making gasoline is as much about economics as it is chemistry. And every step from the crude oil handshake to the final blend has to justify itself in dollars. But behind all that business talk is still the story of transformation. And that story ends right where it began, with you and your engine. Let's bring it home. So here we are, at the finish line of gasoline's absurdly intense glow-up. What started as gooey prehistoric soup buried deep beneath the earth just went through an industrial rite of passage. Boiled, broken, rebuilt, scrubbed, blended, shipped, and pumped into your car like it was nothing. But it is definitely something. Every time you squeeze that gas pump handle, you're holding the last step of a journey that began millions of years ago. And it's not just time, it's tech, it's fire, it's pressure, it's science that borders on art. Refineries don't just make fuel, they craft it. From raw sludge to precision-grade energy designed to start on a frosty morning, haul groceries, power ambulances, or launch road trips. And all of it has to meet exacting standards, not just to keep your engine humming, but to meet laws, cut pollution, and avoid ticking off regulators. It's a global performance with no room for error. One bad blend, one leaky pipeline, one sulfur hiccup, it's headlines, it's lawsuits, it's billion-dollar headaches. But when it works, and it usually does, it's seamless. You fill up, drive off, and never think about it again. That's the beauty of gasoline. Invisible when it works, unforgettable when it doesn't. So next time you're on the road, give a quiet nod to the invisible army of towers, tanks, pipes, and chemical wizards who made your ride possible. If that refinery journey blew your mind even half as much as it melted crude oil, you know what to do. Hit that like button, subscribe, and smash the bell so you never miss another deep dive into how the world really works. Got questions? Drop them in the comments. Got a weird fascination with jet fuel, diesel engines, or how asphalt ends up on roads? We've got episodes brewing. Until next time, fuel your brain, not just your tank.